Thank you very much, everybody, and it's great to see all of these faces at IAB Tech Lab who I feel like I've worked with for a long time now. It's been 2 years since the last event, so yeah, a lot of you are very familiar, some new faces as well. Good to see you all. So what I'm going to talk about is edge computing and also on-device computing. They share a lot of the same terminologies. And what it really means is your device does the work instead, not our servers anymore. It's cheaper for us, it's better for us, and it's better for your data. There seems to be this roundabout of jumping between we're doing it on the server versus we're doing it on your device throughout history. You know, it started with the very first computers and really, really small microchips, and then it went to mainframes, so you would schedule your job on a mainframe. And then it went back to desktop computers, and everything was done on your Windows XP. And then it was cloud computing was the big keyword. And now it's edge computing again. So we're doing this big flip-flop, and here's the latest is let's do it on the device, because now with these things, we've got enough power in here as we did on desktop computers just a few years ago. So when do you use it? And while it can be used for everybody, there are some key considerations where if any of these apply as true to you, then it's a really good idea to start using edge computing. So when users are unauthenticated, if you don't have an ID, if you don't know who that user is, you've got a really good chance here. When data can't be shared as well, when you need to keep that private, when you're not allowed to move that data to other parties, really good for you. And when there's rich application information, so if you have an app or a website where you've got news articles, interactive content, a lot of variability in there, then you can learn a lot of information. So really what edge computing is reading between the lines. This is about, it's a first-party data, and while first-party can give you a statement like this user is on a productivity app, or it might be something they've shared saying they're particularly interested in a genre of music, you can find buried treasure with edge computing like a diamond in the rough. It's pulling out information that you otherwise wouldn't be able to get just by asking a user or just by reading their preferences. So here are some examples, and I've put first-party data in gray here, but it's by no means inferior. This is just that edge computing sits on top of first-party data as something extra that you can do. And some examples here, you've got activity recognition. So what is that user doing while they're interacting with content? You've got ad gaze. So how long is the user dwelling on an ad? You've got level of engagement. So are they clicking on content, certain content more than others? And then you've got the taxonomies that we're working at with IAB Tech Labs. So the audience taxonomy is a great example of this. It buckets people into how they behave. The content taxonomy is describing what is that content about, what site are they on, what app are they on. So I'm going to give you an example and run through the full OpenRTB seller-defined audiences spec and what that would look like in an edge computing world. So here are some of the ideas that we at NumberEight create. So green thumbs is somebody who's kind of into gardening. And we'll learn this through their behavior while using an app. So we'll know if they're at home and if they're outdoors by ambient light sensors. So if they're spending a lot of time outdoors, then we'll say, oh, okay, maybe they're interested in gardening. And then we've got outdoor adventurers. So if you're into nature parks, this might be through some GPS data, or it could be that you're often walking a lot. Then we'll say, oh, you're an outdoor adventurer as well. And we also have a level of live data. So just something as simple as headphones being connected means that perhaps an audio ad is going to be really useful for you at this moment in time. So this information makes its way into the OpenRTB spec. And we can see that we've added the NumberEight IDs onto this bid request. But noticeably absent is anything like GPS data, the sensor data that went into this. Any of the information about the user, the IDs of that user is all gone. And you're just left with the segments that matter. If you wanted to use the taxonomy IDs, then yeah, those get mapped on as well. So you've got a common parlance that everybody can speak, and this will relate to the IB audience taxonomy. So the bigger picture in this is you've removed IP addresses, you've removed find location, you've removed IDs of the user, but you're still able to get a really rich picture about what that person is about, what they're doing, but without sharing that information beyond what's really necessary and beyond what is the purpose of the activity of I'm giving a targeted advertisement, but not to a particular individual. I'm just giving something for the moment. So yeah, we've got some risks. What happens if you have too much of this? So if we have somebody that we know is age 40 to 60, a business owner, owns an electric car, tweets about Dogecoin a lot, we're starting to get a picture about who this might be. So we've got to stop that from happening. And as we've been talking about before, and Manmeet's done a great job about talking about k-anonymity and differential privacy, but what you want to make sure is that you never get a k=1 situation with your k-anonymity. That's when the data controller is very, very sorry, because it means that everybody is identifiable through their unique attributes. So briefly, yeah, with k-anonymity, some things in there with very small font. Not sure what happened there. If you were to say that k=1000, that means you take any user in a data set, and they are identical to at least 999 other people. So you can understand that if it's 1, then they're identical to no other people. And that's bad because you then have a unique identifier. So we're avoiding this eventuality. And the mitigations, yeah, we talked about a couple of these already. So limiting your number of audiences to a handful, and what Google Topics has been talking about is saying, let's leave it to 5. With 5, we can control roughly what's happening here, and we've got a very limited chance of an overlap that would cause a k=1 situation. You also can't do hyper-precision audiences. So we can't make an audience of people that would just concatenate business owner into Dogecoin, really liking rockets. That is way too niche. You're going to get one person in that. Let's not use that. Let's keep it to, say, 50 people minimum in a particular cohort. Again, adding noise. So talking about that earlier. If you add random data but not too much, you're still getting the utility out of it, but you're not introducing, you're not able to distinctly identify that user because there is an element of guesswork there. And then lastly, I'll just talk about an entropy budget. We talked about this in the IB Tech Lab in a separate working group about what we can do to try and make a better estimation about how many users we're really able to target down to. So here's an example. If you understand a little bit about the user base of your audiences, let's say we've got some high precision ones that are less than 5% of your audience base. So let's say people who are into rocketry. If you want to use that, then you can introduce a high cost for this, and we'll say 10 points if you want to use a high precision audience. If it's medium, auto intenders, then it's 3 points. Or if it's low precision, like male or female, then it's 1 point. So you could use a combination of these, but you couldn't have 2 high precision ones because that would blow your budget of 15. And you couldn't use 20 3-pointers because that would blow your budget as well, but you can do something in between. And then differential privacy here. So yeah, again, this was talked about a little bit. And this trusted intermediary, the job is to prevent somebody from listening in and piecing together that information and figuring out who that person is over a lot of web requests. So you might have 20 different audiences, and if 5 were sent at a time, if you listen for long enough, you might be able to identify all the audiences that that person belongs to. So by having an intermediary there, which can also be on the same device, it could be on the same browser, or it could be a trusted server, which I know Grant from Triple Lift will be talking about. Then you can start adding some extra noise, adding and blocking out some data, introducing some things to throw off potential malicious actors. And then you've got on-device auctions. So Fledge does this, and yeah, thanks for the talk about Fledge earlier with topics. What you can do here is do remarketing. So when you go over to a website or an app, and you've, let's say, put a basketball in your shopping cart, we know that that person is now interested in buying a basketball. But instead of sharing that information with everybody, it actually gets saved back to the device. And the device is now in control of that information. The next step is the device runs an auction. So instead of that auction being run on a server somewhere, we're doing it on the device. And the device already knows that it's joined an interest group for basketballs because the e-commerce site has told it to do so. So now it gets a list of adverts all about various topics, and it picks out the one with a basketball, and it prefers it. It says, this is better for me. But it hasn't had to tell anybody that it ever had a basketball in its shopping basket. So this is where NumberEight fits in. What we do is we take sensor data on the device along with other signals and try to repackage it in a way that is useful for on-device audiences, for information that doesn't require sending GPS and sensor data to whoever knows where. And it condenses this information first into a layer that says, okay, this person is currently sitting down, or they're commuting, they're on a bus, or they're outdoors in a park. And then by looking at that data over time, just within the usage of that app, you can start to understand how that user interacts with that app and where they are. So perhaps they play games when they're commuting. Perhaps they go to a shopping site when they're at home. That information is then useful to understand exactly what their needs are and exactly what audiences they belong to without having to send that over to other parties who can then store that and use that later. So thank you, everyone, and I'll be around at the cocktails later if you have any questions.